So this is basically FRQ3, right? I told you guys, whenever you deal with FRQ3, right, you're basically gonna model a periodic context problem, right? You're always gonna get this format. Always, always, always. I told you guys, when you go to FRQ3, as soon as you start it, you don't even want to read nothing, right? You want to tackle easiest points, right? Right, Leo? So you want to try to get the easiest points. So start off with C, the second section. It's the final part, right? The easiest section, easiest point you're going to get in the whole exam. So what do I do here? Well, basically it's telling you, describe how the rate of change. So there you go, the rate of change, right? So rate of change has to do with concavity. Is it concave up or is it concave down? So based on the interval T1 and T2, well, on section C, section C, T1 and T2 are labeled as K and P. So go over here to the graph. Where is it? K and P. I have no idea what these values are. Nothing, no idea. All I know is that I'm able to solve for concavity, right, without any numbers. So is this concave up or concave down? Clearly, this is part of concave down. So you could state here that rate of change, right? I'm just gonna abbreviate it, or I'm just gonna write it down. Rate of change is, well, what's happening? What happens to the rate of change? Well, it's decreasing when it's concave down. So it's decreasing on the interval. Literally, you're just copy and pasting the what's given, the text that's given. Decreasing on the interval. Alright, I'm just going to continue writing it over here. On the interval T1, comma T2, because it's concave. What's concave down? And there you go. Easiest point from the whole exam on section FRQ3, section C2. Rate of change is decreasing on the interval T1 to T2 because it is clearly concave down. That is literally all you have to write down. Now, let's focus on the actual problem. So if I could erase this real quick, and we focus on the actual problem, right? And we go back over here. Let's read it, right? The blades of an electric fan rotate in a clockwise direction and complete 5 rotations every second. Point B is on the tip of one of the fan blades, and it is clearly located directly above the center of the fan at t equals to 0 seconds, as indicated in the figure. Point B is 6 inches from the center of the fan. The center of the fan is 20 inches above the level of the table on which the fan sits, right? As the fan blade rotates at a constant speed, the distance between B and the surface of the table periodically decrease and increase, right? So what's happening here? Out of all this gibberish, what do I get from it? So I always want you to focus here. I don't know if you guys noticed this little text that I wrote down, right? When you're dealing with one revolution, that means you're talking about the period. If you get something where instead of one revolution, it says something, a number greater than 1, then you're dealing with frequency. So let's go back here, right? If I look at the first sentence, it says it completes 5 rotations every seconds. So clearly this is frequency, right? Because I have 5 rotations. I'm only focused on 1. That's my goal. That's what I'm trying to get. So from here, instead of having 5, I'm gonna take this, right, and turn it into a fraction. So this is gonna be 1 over 5, or basically 0.2, right? You can leave it in fraction, or you can put it as a decimal, up to you, right? In this FRQ, you don't get no calculator, so just be aware of that. So from here, right, I start out with 0.2. So my cycle, or my period, goes from maximum to maximum because I can take this, copy paste it over there to the right, copy paste it to the left. So I start off at 0.2, right? So we're starting at 0. So what's half of 0.2? Well, it's 0.1, right? What's half of 0.1? It's literally 0.5, right? So now, if I add the 0.5 plus, I'm sorry, not 0.5, 0.05.
Yeah.
If I add these together, right, then I get 0.15, right? So there we go. Without even trying, right, without even stressing, we already got a point for part A. And part A, all they want you to find, you get a point if you find all the x values, you get a point if you find all the y values. So let's try to figure out all the y values. So what else does it tell me? Well, question, right? Random question. Why did I put 0 here? My timer started to where? Well, 0 seconds, okay? So just be aware of that. So now, is it always going to start at 0? No. At the mock exam, is it going to start at 0? Yes, okay? But it's never going to be this easy, okay? Just be aware of that. So now, what else does it tell me? So I know that I need to find my midline before I do anything, right? So from the floor or the surface to the center of the fan, how many inches was it? So it says here it's exactly it's 20 inches, right? So it's 20 inches. So then going from here to here, right? And then it tells me from point B, which is all the way over here to the top, right? It's gonna be 6 inches from the center of the fan. So from here it's 6 inches, right? So now, going based on this, I believe, let me just carefully look at it, right? The center of the fan is 20 inches above the table which the fan sits. Yeah, basically. So here it is, right? So in the very top, in the very maximum, you have literally 26. What is he trying to do? He has 26 inches, right? Because how did I get that number? Well, I just added these two, right? So from here to here, this is 20 inches, right? And then how do I figure out my minimum? How do I figure out this from right here? So I take these 20 and subtract these 6. I end up at, well, 14 inches, right? So here we go. If I start at my maximum at 0, I start at 26. So that means this is 26. If that is 26, that means when I do the whole revolution around the fan, right, clockwise, right, I'm gonna end up back where I started. So I should end up at 26. Right? Here we go. So from there, right, what happens? Well, right here, obviously my midline, this dashed line, my midline, this midline, right? I'm able to see that, hey, my midline's right here. My midline is, well, 20, right? It's 20. So 20, right? And then what's my minimum? Well, when I come down here, my minimum is, well, 14. 14, okay? Just be aware of that. So that was part A. We also found part C too, right? So we need part B. So we need to find A, B, C, and D, right? So A, if I could take another color real quick, I'm gonna go back to red, right? For A, you need to figure out what's my amplitude. So looking at this, what's my amplitude? So you have to remember that the amplitude starts from the midline and you go up. Or you start at the midline and you can go down. So here, I have an interval, 6 inches, right, going up, 6 inches going down, so my amplitude is 6. So what's another easy one? Well, the vertical shift. The vertical shift is Z, right? So the vertical shift is D. So vertical shift, as you guys know, it's also the midline. So what's my midline here? Well, 20, right? So it's 2 out of the 4. What about C? Is there a shift going left to right? Well, not really, right? So that one, or actually there is. The shift is actually going to be C is actually going to be equal to 0.05, right? Because we're going to start here, right? Remember the sign. Where's my equation? Where's my equation? I'm trying to find my equation. We're dealing with sign. You have to remember the sign starts in the midline. So for that reason, my point that I'm gonna use is G and not F. If we were doing cosine, then we would start up here. Okay? So just be aware of that. Also, what about what am I missing? A, B, C, D. I'm missing B, right? B, right? What's the actual period, right? So I actually have to do this 2 pi over B, right? to be able to find the equation is period equals 2 pi over b, right? So how do I find b? So b is equal to 2 pi, just switch the p and the p, and there you go. So now, what was my p? My p was this 0.2, right? So here the p gets replaced by 0.2. So now b is equal to, well, whatever that gives you, right? So we're just gonna leave it like that for the most part. This is finish with this video because Leo is going all over, right? So another easy one. So C1, the only way to answer it is if all these points are already plotted, right? They're already labeled. So it says here on the interval T1, T2, which of the following is true about H, right? So what is true about this function of H? What's happening? So T1 and T2, we said it was, again, it was K and it was P, right? So where is K and P? K and P is over here. So from K going to P. So this one right here, C1 is function behavior. This does not affect concavity, nor concavity affects function behavior. We know concavity is concave down, rate of change decreases, but that does not mean it's the same thing as this. Okay, just keep that in mind. So what's happening? Is it positive or negative? Remember, if it's negative, it affects my y's. Are my y's any of these y's negative? Well, no. So I can automatically take these two out. So think of it like this. Remember, you have the plus, 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 minus, minus, minus. So what's happening here? Am I increasing or decreasing? And the answer is that you're, well, increasing, right? So the obvious answer for C1 is, well, A. And that's basically it. Hopefully you guys understood it. Hopefully you guys keep this in mind. You guys have to remember the difference between frequency and period. One revolution, that signifies a period. If there's more than one revolution, just like in this case, well, you have to swap it, right? That whole number, which was 5 in our case, got switched to a fraction, and we just used a decimal. But honestly, just so you're aware, if you want to use a fraction, you can, right? You just keep 1 over 5, right? What happens if you divide 1 over 5 by 2? Well, it's 1 over 10. And then again, this is what happens if you divide it again? So it's 1 over 20, and so on. You would add these two here to get this one, right? But I'll just leave it there. This is basically it, okay? Good luck.